here's our next example. It's a little bit trickier. There definitely will be more steps with this problem. Our numerator is 4 over x squared minus 25 minus 5 over x plus 5. That's our entire numerator. All of that over 6 over x minus 5 plus 2 over x squared minus 25. Now, depending on your experience and the methods that you've seen, you might think about, well, can I multiply all the fractions by the common denominator? And yes, and that's really our other method. And for now, I'm going to focus primarily on one method that we've been using so far. So definitely there is another way out there. If you have some ideas about that don't really match how I'm doing these problems, understand they're both ways that will take us to the same final answer. So my approach is parentheses around the entire numerator, around the entire denominator. And now I have basically two separate problems I need to work. I have a subtraction problem I need to work. I have an addition problem that I need to work. So let's pull that numerator down to work with. 4 over x squared minus 25, I'm sorry, that's a minus 5 over x plus 5. Okay, so what are our steps for doing this subtraction problem with fractions? For adding and subtracting fractions, we need a common denominator, and we don't have that yet. So first is finding this common denominator, and that starts with making sure that every denominator is factored. So there's a difference of squares, x plus 5 with x minus 5. This denominator, x plus 5, we cannot factor that anymore. I'll just rewrite it in parentheses, x plus 5. So thinking about what I want to use for the common denominator, I need to use every type of factor that I see in these denominators. And I see some x plus 5s and I see an x minus 5. Definitely they'll both need to be included. But the question is, how many times do I need each of these factors? And it really depends on what's the most number of times we see a factor in any one place. So what that means is, thinking about the x plus 5s, I see it a total of 2 times, but that's not how I want to look at it. Not like the total, but how many x plus 5s do I see in this fraction? Just 1. And how many x plus 5s do I have in this one? Just 1. 1 here, 1 here, means that for the common denominator, 1 is enough. 1x plus 5. We'll need an x minus 5. Here we see it once. Here we see it not at all. So here it's where we see it the most, where we have it just once. We need 1x minus 5. Our next step is to build equivalent fractions that have this common denominator. And our first one, the 4 over x plus 5, x minus 5, is in perfect shape, all set to go. No change needed, but this fraction does need a change. We've got for the denominator x plus 5, but we need x minus 5. We're multiplying that to top and bottom. And I'm going to rewrite these fractions. Slide the page up a little. The first one we said needed no change, so that's 4 over x plus 5, x minus 5. It's a subtract problem. Denominator, now we do see our LCD, x plus 5, x minus 5, and the good rule of thumb is that we always like to leave the denominators factored. But the numerator, we definitely want to multiply, because our next move is to combine like terms in the numerators. So I want to do a multiply, a distribute, to have 5x minus 25 in the numerator. Okay, we are close to being able to put these two fractions together. There's one little thing that's I need to just be very careful about, and it has to do with the subtraction problem. When I'm combining like terms, when it's a subtract, what I really like to do to make sure that this subtract gets applied to every term in this numerator, which it has to, I'll say make that minus and add, and I'm going to go through and on my own flip the signs of each of these terms. I flip my 5x into a minus 5x, and I'll flip this minus 25 into a plus 25. And that's my way of making sure that all of my signs are going to be right on the money, and I need to just combine like terms now. LCD, it's not going to change, x plus 5 with x minus 5. In the numerator, combining like terms, I'm looking at positive 4 with positive 25. Those will go together. negative 5x, no other x terms in the numerator. So right now it's negative 5x plus 29. And all of that was just a numerator, but I'm okay with that. I know that these are problems that are going to take several steps. Maybe that's unfortunate, but I can tell you the upshot. What we've done so far is not new. If you learned how to add and subtract fractions, then those are just the steps that we're using over and over again. There's nothing new that I need to know about complex fractions. I just need to know how to add them and subtract them, and when I get to the end of the problem, I remember how to divide fractions. So there's our numerator. Next, we need to take this denominator. Okay, I've just organized my work a little bit. I sectioned off this work that I did with the numerator, and I've got it labeled there. Definitely want to have some organization for when I need to finish this problem, but I've got myself some space for working with the denominator. And in the denominator, we have 6 over x minus 5 plus 2 over x squared minus 25. We'll be doing the same steps we did up here with the subtract. Subtract and add have almost identical steps. They're just little details to be cautious about with subtract, flipping signs. With add, we won't see any signs that we need to flip. But we do need to find the common denominator. We need to make sure all the denominators are factored first, so that's x plus 5 and x minus 5. The first fraction, x minus 5, we cannot factor that any further. Our common denominator, it's actually going to be the same. Another x plus 5 with x minus 5. The second fraction does not need any change. It has that common denominator, but the first fraction needs an x plus 5. If that's what the denominator needs, the numerator must also get it. Top and bottom gets times x plus 5. So what do our fractions look like now? We want to multiply in the numerators. Looks like a 6x plus 30. Denominator is where we have our LCD, x minus 5, x plus 5. Second fraction, no change. It's still 2 over x plus 5, x minus 5. It's an addition problem, so we are ready to combine like terms. The denominator won't change. It's still our LCD, x plus 5, x minus 5. And I'm looking for like terms in the numerator that I can combine. No other x terms with the 6x, but the positive 30 and this positive 2 we can combine. So there's the 6x and plus 32. There's our denominator. The final step is going to be doing a division with numerator and denominator.